And she came to me with just an abundance of experiences, and I knew from like the very first day that she had incredible lab technique, but not only that, I knew we would work really well together because we both like organized, and we both like to chat sometimes. So I think I didn't make it easy for Michelle to do this project. I was not taking students, and she had to be really resilient and really independent to kind of take some of the work we had been doing on air quality during COVID and expand it to this new exciting realm of thinking about indoor air quality in general, which is a wonderful benefit of COVID times that we never knew we would have. But she was resilient and persevered, and what you're gonna see today is really all about that work, how she pushed even me through this project to create something new and wonderful. In that time, I've just had such joy getting to know Michelle's work ethic and her great experimental design skills and her ability to interact and interpret data. And most importantly, just her amazing human spirit and what a wonderful person she is. So I am proud to have her as a student. I am proud to call her a friend. And I am sure that you all are gonna be just as excited as I am to see this project that ran into many problems, still getting there, but we are very excited to present this next step in indoor air quality at Lawrence. I'll pass it to you now.
Thank you so much for your kind words, Diana. So, hi everyone. Thank you all for being here today, and I hope you're all doing well. So today I will talk about a very important topic that often go unnoticed in our school, which is the indoor air quality analysis, and more specifically, the analysis of volatile organic compounds in our library. And as we strive to create a healthy and safe indoor space, indoor environment for everyone here, improving and maintaining a healthy level of indoor air quality is very important. And my project was built upon the previous work by Gloria Gonzalez, who graduated from 2022. And while her project focused on like COVID data, mine was focused on, obviously, the volatile organic compounds, or VOC, analysis in the library. And in this presentation, we will explore the significance of VOCs, their effect on the air that we breathe, and the methodologies that we use to analyze VOCs in the library. And before we get into the details, let's all take a step back and make sure that we all understand what exactly indoor air quality is and why should we care about it. And indoor air quality refers to the air quality within and around buildings and structure. It is known to affect health, comfort, and well-being of building occupants. And why we often associate air quality with the outdoor air quality only, it is important to know that indoor air quality is equally important because we spend 90% of our life indoor. And it is also worth to note that indoor air quality is closely linked to outdoor air quality since the air indoor originates from the outdoors. However, due to the confined nature of indoor spaces, the pollutants can accumulate, which leads to 2 to 5 times more pollution indoors than outdoors. And here's some of the very common indoor pollutants, which is airborne particles, volatile organic compounds, ozone, and carbon dioxide. These can originate from the building materials, human activity indoors, such as cooking, and obviously from the outdoor. And according to our World in Data website, indoor air pollution is a leading a leading risk factor for premature death, resulting in 2.31 million deaths per year. Million deaths globally in 2019. And even though the annual deaths from indoor air pollution have declined a lot since 1990, it was still attributed to 4.1% of global deaths and remain a major environmental and health issue in lower income countries. And to ensure a healthy and safe indoor environment, at Lawrence, we have been closely monitoring indoor air quality in different places around campus, including the library. And here is what we use to evaluate the data. Here's the Omni sensor. You can see it's still working without an electrical source for quite some time. And so for the parameters, there are temperature, humidity, carbon dioxide, VOC or volatile organic compounds, and FIDUS or PM 2.5. These parameters are represented on the device over here as a sequential dot, and the fewer dots appear on the device, the healthier ours. And right now, because I'm breathing into the device, the humidity and CO2 kind of increase a little bit, but in general, the air quality is looking pretty good right now. And the sensors can also detect ambient noise and ambient light. And overall, after evaluating all the parameters, it calculates the awareness score to give us like a general, to tell the users about the general surrounding air quality. And if you don't like numbers, like I do, you can look at the standard indicator. If it's green, it indicates good surrounding air quality. Yellows mean fair, and poor and red means poor, and you should get out of there or do something else about it. And in this presentation, our primary focus will be on investigating the concentration of VOCs. And what exactly are VOCs? So VOCs are volatile organic compounds, which are organic chemicals that evaporate very easily at room temperature. They contain a variety of small and complex compounds emitted from liquid or solids that are very hard to separate. They are known to have a major impact on our indoor air quality and human health. For example, formaldehyde, a very common VOC that released from the building materials, have been shown to cause eyes, nose, throat, and skin irritation at low-level exposure, and even leukemia or rare cancers at high-level and long-term exposure. And here is the VOC index. And it is important to try to minimize the VOC level under 3,333 parts per billion, but ideally under 333 parts per billion. And based on the data collected by our sensors, high concentration of pollutants in the library have been observed. And we also received report from the library workers that they have been experienced health effects and discomfort while working in the library, such as worsening asthma and allergy, headache and nausea, sneezing and coughing, and some irritations, which mask with the symptoms of being exposed to indoor air pollution. And here's an example of a time that we saw unusually high peaks in the library. This data was collected by Gloria during her COVID project. And we are still very unsure of what caused the high level of VOC. But it is important to note that these observations correlate with the symptoms that was reported by the library workers about indoor air pollution. And here's another example of our attempt to explain the observed VOC peaks. As we know, outdoor air quality is the start of indoor air quality. So we try to compare our data across different places around campus. So we have collected data from the Andrew Commons, Wellness Center, Watch Info Desk, and obviously the library. And there are some peaks that correlate to each other, suggesting the high level of VOCs actually came from the outdoors. However, we also saw consistently higher peaks from the library with no coordination to any other places around campus. So based on this, we thought that there might be a VOC source within the library itself. And we can also look at the baseline of VOC concentrations in the library and why it is also much higher compared to other places. And we can see that the VOC baseline in the library was in the good range, and while the other places had VOC concentrations in the ideal or very great range. And these data provide the evidence to strengthen the possibility of having a VOC source within the library itself. And that makes us think what the library has the most, obviously books. So we suggest that paper degradation is a possible major source of VOC in the library. And it is known that the stability of paper is greatly influenced by its productions. So before 1850, Asian paper were mostly made by linen and cotton rag, which contains more than 80% of cellulose. This makes the paper extremely long-lasting. However, as the demand of paper increased since the 19th century, the industry paper made from 1850 to 1990 were mostly made by wood pulp and sometimes straws. This material only contained 50% of cellulose, and the other 50% were hemicellulose, lignin, and other additives that used to preserve the paper. However, the paper made from this area in this period was very acidic, which made it much less stable than the ancient paper. So to overcome the acid degradation in the industry paper, our modern paper made after 1990 was treated with alkaline buffer to neutralize the acid to help decreasing the degradation process of the paper. And furfural and acetic acid have been attributed to cellulose, and hemicellulose degradation. And as I mentioned before, the Asian paper was mostly made out of cellulose, which make it main degraded product is acetic acid. On the other hand, industrial paper was made from both cellulose and hemicellulose. And hemicellulose, through hydrolysis, will be broken down into xylose and arabinose, and finally further broken down to furfural. And acetic acid that degrades from cellulose and the acidic paper will auto-catalyze the hemicellulose hydrolysis process and further increase the rate of paper degradation. Now let's shift our focus to the methods and results of our VOC analysis. In this section, I will walk you through different approaches that was used to measure the VOC emissions in the library and the key findings that we have obtained. So we use 3 different sampling methods to investigate the VOC emissions. The passive sampling test was performed by placing the Omni sensors, just like this, in different areas in the library that have different book density. And we were also curious about if the sensors could detect VOC emitted from the books. To do that, we perform the active sampling by book flipping. So basically, I have the sensor over here facing toward me, and the books, I just flipping it like this for a couple of minutes. This is an older book, so it's harder to flip. And finally, we also had a controlled passive off-gassing experiment that in the chambers. We hope to see an elevated VOC levels and test the levels of fluoro and acetic acid emitted from the books through detection test tube. So basically, the books go in here with a sensor, and I just leave them like that for a couple of days. With the lid on too, sorry, like this. And here's the results that we observed through these experiments. So since the data is collected every 5 minutes for 58 days, we had a lot of observations which make our experiment quite robust. The disk area on the first floor does not contain any books and was used as a reference. However, we still can see the average VOC concentration was pretty high, and this suggests that books might not be the only source, the VOC source in the library. Moving on to the A level, it has the lowest VOC concentration here, which is as we expected because in A level, the books collection are much newer, with most of them are published after the 2000. Because since the books haven't degraded as much, so it is expected to have a lower VOC concentration. And moving on to the archive area, where I suppose it has a lot of older books. However, due to it being restricted to the public, I did not have a lot of information about it. But we can also see it has a pretty low level of VOC compared to other areas. This suggests that the areas might actually good at preserving the books, or alternatively, the sensor was placed so far away from the books, resulting in the lower VOC readings. And finally, in the third and fourth floor, they have much higher VOC concentration. While the third floor mostly has the acidic books that was made from the industry period that from 1850 to 1990, the book collections on the fourth floor consists of many books from different periods. And the big standard deviation error bars tell us that the data is widely spread and there are a lot of variation. And moving on to the active sampling experiment, the baseline was collected by just me standing in front of the sensor, just like this, doing nothing for the whole 5 minutes. And then after that, I flipped the books. Each book was flipped like this for like 2 or 3 minutes. And the experiment lasts for half an hour. And we can see these data are consistent with what we saw in the previous slide, where the third and fourth floor has higher VOC concentration than the A level. And last but not least, we have our controlled passive chamber experiment. What we are seeing over here is very interesting and also tricky. And we saw a very obvious Dyno cycle from the chamber itself. So the sensors goes here, and there was no book over here. We collected as to hope to see just a flat baseline, but instead we saw this one. This is very interesting because it suggests that the chamber itself was emitting VOCs, and the VOC was broken down by the sunlight because we saw higher the VOC concentration. VOCs was built up at night, so higher level over there, and it was broken down by sunlight during the daytime. And this also suggests the existence of formaldehyde because formaldehyde is able of absorbing UV light and also photolize during the sunlight. Formaldehyde. And there are two different pathways for formaldehyde to photolize. The first one refers to as the radical channel, where formaldehyde is broken down into formyl radical and a photon, while the second pathway is called the molecular channel. The molecular channel, where hydrogen and carbon monoxide are produced. And going back to our experiment, after the first 3 days of collecting data without any books in there, we put this book in and hope to see, what we hope to see was an elevated VOC concentration because fluoro and acetic acid are not able to photolize at room temperature. It was very promising during the first 2 days because we saw like much higher peaks of VOC, but then sadly after that, the level came back to normal and even lower during the last 2 days. And so in conclusion, through the experiment, we confirmed that the 1950 to 1950 books tends to emit more VOCs, and the books are not the only VOC source in the library. And everything is VOC sources, as I said before, from the outdoors, from the building materials, and human activities. And the diurnal cycle observed from the off-gassing experiment suggests a possible existence of formaldehyde. And we also have an unideal chamber. So obviously, the first step for future direction is getting a new chamber with limited VOC emission. And we also hope to carry out the experiment a little bit longer to see if there's any special trend that we saw with the diurnal cycle. And if we are able to trap the VOC emitted from the books, we hope to categorize them by using detection tube test, GCMS, or FTIR. And finally, I would like to acknowledge several individuals that helped me throughout this project. First, I would like to thank Professor Diana Donohue. Thank you so much for being my advisor for this project. And thank you for being so patient with me when I could not keep myself together. It is my honor to be your student. And I also like to to acknowledge Professor Graham Sadama and Professor Stephen Debrek for helping me for their helpful feedbacks and just finalizing my presentation. I would like to also thank the Senior Experience Fund for making this project into reality. And finally, my family, who unfortunately could not be here today with me, but without their continuous emotional and financial support for the last 22 years, I would not even be here today. Thank you all for being here. Thank you to Kami that helped me go into the library and setting up the experience with me. And thank you all for being here today. Questions?